we're going to integrate the following. Now, because these are side by side, x times e to the 2x, it means it's a product. So we have to use by parts in order to integrate. We always assign the simpler one to be u. How do we know which is the simpler one? It's the one that when I differentiate, eventually I'll arrive at a constant. A constant meaning a number. So here we assign u to be x and dv to be e to the 2x. So what we're going to do now, the one that we assign to be u, we differentiate, and that's why I have the 1. And we integrate the dv at all times. We integrate dv to get v. So integrating it, we have a half e to the 2x. Once we arrive at what is u, v, u prime, and dv is the same thing as me saying v prime. Same thing. Now, we are going to substitute into by parts formula. On the left-hand side of the formula is basically the question, which is what we have here. On the right-hand side, we are going to substitute what is u and what is v. So u, that is x, which is what I have here. V, half e to the 2x, which is what I have here. Again, v, half e to the 2x, and then u prime is 1. Now if you realize I have the 1 at the front, now you could have had it at the back as how it is placed in the formula, but by right, order doesn't matter. So it doesn't matter where you want to put the 1. It can be in front or behind the e to the 2x. Now the next step is for us to multiply a half times 1 to give me a half. We can factor out the half. So what we can have, so that you don't get confused, is to have the half in front of the integral sign. So you can remove the half here, factor it out. So you have e to the 2x, and we know that when you integrate e to the 2x, it's the same thing as a half e to the 2x, or we can write it as e to the 2x over 2. These are the same thing. Now, after going ahead and integrating to get e to the 2x over 2 plus c, we multiply 2 times 2 to give us 4, and 1 times e to the 2x to give you e to the 2x. So all of this will be our answer. X times half e to the 2x minus e to the 2x over 4 plus c. Here we have another activity, which is x squared e to the 2x. So what we're going to do, we're going to assign 1 to be u and 1 to be dv. Now, u is always the one that when we differentiate, no matter how many times, eventually we'll arrive at a constant. So x squared, when we differentiate x squared twice, we will arrive at a constant. Now, the fact that I have x squared, it means that we are going to apply the by parts formula twice. So here we have x squared. It will give me 2x when I differentiate it. While when we integrate e to the 2x, we already know it's going to be a half e to the 2x. Now, we are going to go ahead and substitute into the formula, which is what I have in red. So my u substituting u, it's going to be x squared. My v substituting is half e to the 2x. V again, which is half e to the 2x. And my u prime, that's going to be 2x. No. This 2 and this half, we can simplify it. 2 times a half. What's going to happen is that 2 into 2 goes 1 time. So in other words, they cancel to give you 1. So what we're left with is just x times e to the 2x. No, you don't have to do that. You could continue with it. But I like to simplify. No, I am going to use a different color. Let's use green. We're going to apply by parts again to this. So we have to integrate this green once more, which is what I had put aside here. So we're integrating this again because we have a product. So we have to assign 1 to be u, which is the x, and e to the 2x to be dv. We differentiate u to get 1, and we integrate e to the 2x to get half e to the 2x. We have to apply the by parts formula, which is what I have in red. So our u is x, so this x that I have here, and then our v is a half e to the 2x, which is what I have here, and then v again, so it's a half e to the 2x, and then u prime, which is the 1 here, which is what I have here. Now we multiply a half times 1, that gives us this a half. Then you can factor out the half. So if I factor out the half, it means I can put a half in front of the integral sign and remove it from here. Then we integrate e to the 2x to get e to the 2x over 2. Remember I said this is the same, half e to the 2x is the same as e to the 2x. X not writing. Over 2. No. When we integrate e to the 2x and get a e to the 2x over 2, we should be simplifying. So 2 times 2, I'm expecting you to do that. Now you don't have to do it now. So remember I've highlighted some things in green, right? So this yellow that I have here, just to explain what's happening now. The green, which is this, let me move it with my cursor. So this green, I'll be replacing it with the yellow that I have here. So all of the green section, which is this, will be replaced with what I have in yellow. So right here, I am going to replace it with the yellow. So that's why I have this square bracket with all of what I have in yellow. So all of this is what we have in yellow. Then the negatives are going to change some signs. So negative times x gives a minus x, half e to the 2x. Then this negative times the next negative here would give us a positive right here. And then you can change the sign for this to be minus or leave it because we don't know what you see. But I'm expecting to see 2 times 2 to give you 4. So the answer for this would be x squared half e to the 2x minus x half e to the 2x plus e to the 2x plus 4, 2x over 4 minus c. I don't have to make a lot of correction.